Getting started in game development can be very hard, especially if you don't have any programming background like me. So I'm a game designer, I didn't have any coding background before getting started with game development, and I had to make my way out of that because I wanted to make digital games and I didn't have any partner that could help me with coding. So throughout this journey I realized that there are three major skills that you should master in order to create digital games, and that's what we are going to talk about in this video. So in my mentorship program, the Mission Selene, which I'm going to talk more about later on in this video, I like to call this method the 3 eyes. So you have to open all the 3 eyes, which each one of them is one skill. It's basically a wordplay because each one of them is an I, like the letter I. So basically we pronounce the I, the organ I, just like we pronounce the letter I. But let's start with the first I. Let's start opening the first I, which is the I of input. When we are creating a game, we are making an interactive media. It's very different from a movie or from a book or from music, because in games, the players have the ability to change the narrative. It's different from a movie where the audience is passive to the story that the director or the screenwriter is telling to them. But in games, we as game developers, we as game designers and game directors, we are co-authors of the player's stories. So they are writing their own stories based on the tools that we give to them, that we provide to them. And for that, they have to interact with this media somehow. And to this interaction, they need an interface, a device that will allow them to interact with this virtual world. And to that, we give the name of input method. And when players interact with these input methods, they create events. So for instance, an input device can be a keyboard or the mouse or the touch screen, so on and so forth. And an input event is something that happened to this device. So for instance, if the players move the mouse, if players press the left mouse button, if players press a given key, and we read these events and we provide a feedback to them. So players interact with the game should provide something in return, which we call an event as well. But this time is a game event. So for instance, when players press the spacebar key, the character jumps. When the players press the D key, the character moves to the right. When players press the A key, the character moves to the left, so on and so forth. Something should happen when players interact with these input devices. The overall idea here is to separate what is the device and what is the input event, because what we are actually interested in knowing is the input event in itself. Did the player press? Did the player release this key? Did the player move the mouse button? Did the player create a given gesture in this touchscreen device? So that everything can be managed in the game. In that sense, Godot Engine provides 3 major ways to access these input events. And well, actually 2 major ways to access these input events and 1 way to access the input devices. So let's talk about them. Before we start understanding how input handling works in Godot Engine, we need to understand how the Godot Engine actually works. So Godot Engine follows a design pattern called composition tree, where we have objects that can make references to the same class, which in our case are nodes. And this creates a hierarchy of references that these nodes have. So we call this the scene tree. So a node can make a reference to another node by making this other node a child of this parent node, so on and so forth. And this creates this scene tree hierarchy. The scene tree is what Godot's call the main loop, which is basically the game loop. The game loop is basically the sequence of processes that the engine will make in order to process the game and render a frame. So in this case, Godot Engine will read all the nodes and will process all the nodes in the scene tree in order, so from top to bottom, and this will allow it to communicate what happens first and what happens later. So based on this order, it will propagate inputs to these nodes, allowing us to give priorities to one or the other. You can also tweak this manually. There is a property called priority in every node, which you can raise to give more priority to a given node. But why does this matter? Well, because when we talk about input events, sometimes we don't want parallel input handling. And for that, we can use the unhandled input method. What does the unhandled input method does? Well, take into account that the scene tree will notify every node that there is a given event, input event that just happened. The player pressed the spacebar. Depending on how you structure your game, you may want to one thing happens and prevent a given behavior from happening. Let me give you an example. Let's say that you are making an RPG game, and for any given reason, in the middle of a given battle, you can talk to an NPC. But if you talk to the NPC, the game doesn't pause. So if you talk to the NPC, the enemy can basically kill your character, your avatar. To prevent that, you can give priority to the input handling by the combat system instead of the interaction system. So if you want to know how you can make an interaction system, I will highly recommend you to watch this video where I show how you can make a very simple one that allows you to talk with NPCs, to collect items, to interact with doors, so on and so forth. But the interesting thing here is that these two things can't happen in parallel. You can't talk to an NPC and interact with a given menu if you are fighting against an enemy. So we have to give a priority for that. But what if, and this is very common, especially if you are using a joystick as main input device, what if the same button that triggers the interaction with the NPC is the button that performs the attack animation? Well, the combat system can consume this event saying, hey, I know that we both want to know if the players press the given button, so let's say the spacebar, but I have a priority and I don't want to propagate it to the interaction system. So I'm going to consume this event and it will stop right here and not propagate to any other node from here. This is going to make so that the player's avatar will perform the attack animation and will not interact with the NPC. So these both things can't happen in parallel. This is what the unhandled input is meant for. So for instance, I already dealt with that because I made a platformer game where the same button for jumping was the button for interacting with NPCs, and players would get close to an NPC, try to talk with them, and will talk with them and jump at the same time, and I didn't want that. What I made was to give priority to the consume of this input event by the interaction system in this specific case. I want that when players get close to an NPC and press the spacebar, they will talk to the NPC instead of jumping, because most of the times in my game, the NPC wouldn't be like close to anything that players will have to maneuver their way out of it. So a given moving platform or a hazard or something like that. So this is one way that you can use the unhandled input to consume an event and prevent it from propagating to other nodes. But if you want to work around this system and actually get access to an input event regardless of if any other node consume it already, you can use the input virtual method or the input callback, which is going to allow you to get access to any input event regardless if it was already consumed by the interface or by other systems. So in the example, if it was already consumed by the combat system or the interaction system or the movement system, you can use the input callback to work around all of that and still get access to this input event. And I will highly recommend you to avoid that, because this can make so that you have parallel processing of these systems. And sometimes you don't want that because this can generate a lot of errors. This has nothing to do specifically with performance. I don't think that this will cause a huge performance issue, but it's more about the actual behavior of the game. Use the input callback very, very strategically. On top of these two virtual methods that Godot offers to us to handle input events, Godot also gives us the ability to read in real time the state of the input methods using the input singleton. It's very important to understand when to use each one of these approaches, because this can cause some performance issues. So it's very common for content creators creating tutorials for beginners to provide a given algorithm for movement. On the physics process, you are going to check using the input singleton if this action is currently pressed. Let's say move left is currently pressed, and if so, you are going to change the direction to move towards the left. Well, what is actually important here is that you are notified whether the player press or release the move left key, right? So there's no need to bloat the physics process with this logic. You just need to be notified when players press or release the move left key or the move left input action. So you can move this logic to the input callback or the unhandled input callback, because you are going to be notified about these events regardless. So in that sense, you are going to free up some space in the physics processing, allowing you to do other stuff like checking for collisions, checking for any kind of physics behavior that you want to insert into your physics processing. So when to actually use each one of these approaches, when to use the callbacks and when to use the input singleton. Well, my rule of thumb here is that if you need to be aware when something just happened, you are going to use the virtual callbacks. So if players press, if the mouse moved, if the players performed a given gesture in the touch screen, so on and so forth. But if you want to check the current state of a given input method, you're going to use the input singleton. And these both approaches can work together as well. So for instance, on my pass-through character, which I'm going to put the link to this tutorial on the screen right now, you can check it how it works there. The pass-through character can pass through platforms by holding down the arrow down key or the S key and pressing the space bar as well. So for that, what I do is inside the unhandled input callback, I check if the space bar, which is the jump action, was just pressed. So it's pressed if this event is in regard to the jump action being pressed. And I also check if when the player press this jump action, if the down key is also pressed. And for that, I use the input singleton. So I can combine these both actions to create a more complex action. So this is one of those cases where you can combine both approaches. But the rule of thumb is that if you want to check the current state of a given input method, you can use the input singleton. If you want something to happen based on a given input event, you basically can use the unhandled input and the input callbacks. But that said, it's time to open the second eye, the eye of interactions. Well, until now, we talked about how the player, the physical player, can interact physically with the game world using inputs. But what happens inside this virtual world? What happens when things interact in this magic circle, as Eric Zimmerman will call it? Well, we need to detect when two objects are interacting with each other. And for that, we can use the physics objects. Well, Godot Engine offers two types of objects for two different scenarios. You can use a body, so a character body, a rigid body, a static body, an animated body, when you need to handle collisions, and you can use area 2Ds when you need to handle overlapping. These two things are mutually excluded because by definition, a collision will prevent overlapping, while on the other hand, an overlapping will not allow a collision. When a collision happens, these objects can't stay together. One object physically can't be on the same place as the other object. On the other hand, the area is something that is more abstract. It's a given place on space that we can set the boundaries of this space and check if another area is inside this given space. Pong is a great example for that, because when the ball reaches a given edge of the screen, it should bounce off, and for that we can use the move and collide method from the character body. And when it detects that a collision happens, we want to have access to some data regarding this collision. And this only happens when we are using a collision object, an object that actually gives a collision, which is not an area 2D. The area 2D in this case, or the area in this case, would be used on the places where players can score. So for instance, behind the rackets, right? And the rackets themselves can be character bodies as well. So they are going to be moving, and when the ball collides with them, they are going to bounce off the ball. It's very important to master the ability to handle interactions, because this is most of what happens in the game. An object will interact with the other, causing some damage. So for instance, a bullet will interact with the player's body, causing some damage. We can create hit and hurt boxes using area 2Ds to detect when the hit box is overlapping with a hurt box, so it can deal some damage. And if you want to create a combat system based on hit and hurt boxes, I will recommend you to watch this video where I explain how you can do that. It's a video about creating hit and hurt boxes for a combat system. But to interact with an NPC, you need to use the area 2Ds as well, because you need to know when did the player entered inside the interaction area of this NPC, and so on and so forth. For instance, if you want to know when the players get inside the lava so we can deal some damage to the player, you need to master how you can do that using these interactions. If you want to know when did the player enter inside the water to decrease the movement speed, you also need to master interactions. So mastering interactions is, I think, that the most fundamental skill out of these three I's. I think that they are very balanced out, but if you want to start with any of these three, start with interactions. Now it's finally time to open your third eye. This must be the best metaphor ever. So the third eye is the eye of instancing, which is the ability to create objects dynamically in runtime. So the idea is that as you create a game, you have to master the life cycle of your game objects. So when they appear on the screen, when they are removed from the screen, when they are removed from memory. In Godot Engine, we have two major types of objects that we are dealing on our every day of game development. We have resources and we have nodes. And as I said previously, Godot Scene tree only processes nodes. Remember, it is a composition tree, and the base class for all of these components are nodes. And nodes can make references for another node by using the children hierarchy. So when we create these references, when we create relationships between nodes, we are creating a node hierarchy. But on the other hand, resources can't be processed directly. So we have to make a reference to these resources inside a given node. Why so? Because Godot Engine Scene tree, the main loop, the game loop, will call all of the process methods, so all of the virtual callbacks, in order to process the logic so that we can inject logic into the given scene tree to make the engine perform what we want in our game. So this is how we actually make Godot Engine become our game. We inject logic inside these virtual methods. When I say virtual methods, I'm referring to the ready callback, the process callback, the physical callback, the input callback, so on and so forth. These are the virtual methods that Godot will automatically call in the main loop, into its game loop, so that it can render our game. And the way that Godot Engine does that is that only nodes can do that. So only nodes are capable of being processed in the scene tree. And if a node doesn't have any relationship to another node, it's not going to be processed. So it doesn't matter if the node is instantiated in memory, it will only be processed if it is a child of another node. And to create this instance of objects, especially the instance of nodes, Godot offers two major ways to do that. When we are using the Godot editor, what we are doing is using an application made in Godot Engine. I don't know if you already know that, but the Godot editor is a game made in Godot Engine. So we are using a runtime application to create some objects, to create the scene tree hierarchy that we want for each one of our nodes, which we call a scene, right? So when we are creating a scene, setting up the relationship between like a sprite and a character body and a rigid body and its collision shape, so on and so forth, what we are creating is the scene hierarchy. Since we are using an application for that, we need to save in memory this relationship of nodes because we want to recreate it in runtime when players are actually running our game. And for that, we can save this scene hierarchy as a packed scene, which is a resource, but is a very specific resource, a resource that is responsible for recreating a scene in real time. And to create this scene in real time, we use the instantiate method. So the instantiate method will read the packed scene resource and will turn it into a node so that this node can be inserted in the scene tree and can be processed. This is the overall logic of using a packed scene in the instantiate method so that we can turn this resource into a node. So the packed scene is a very special type of resource that has the ability to serialize and deserialize node content, so the relationship of nodes. This is an interesting process because serialization is all about saving something in disk so that we can use it later regardless of time or space. This is a very philosophical approach for that. You store it in memory so that you can use on another application, like another game. You can basically copy and paste your packed scene on another game, so it will break the barrier of space, or so that you can use on another time, so breaking the barrier of time. On the other hand, we have the resources. We can't do the same thing for resources. As I say, the packed scene is a resource that is used to recreate the scene that we created using the editor. But as I said, resources are not directly processed by the scene tree. We have to attach them into nodes in order to process them. So Godot also offers the ability to create instances of resources and any other type of object using the new method, or for C# you can use the new keyword before you actually make an instance of an object. What the new keyword will do, the new method will do, is that it will basically create an instance of this object in memory. But as I said, in order to make it process, you have to attach it to a node. So you have to make this reference, you have to create this instance, and then you can attach it to a given node so that the node can actually process it. You can also use the new keyword for nodes, but when you do that, you're not going to deserialize the scene tree. You're just going to create a new instance of the node class. So let's say that you are making a player class and you use the new keyword to create an instance of a player. This is going to be an instance of the node of the player class and not an instance of the whole player hierarchy. So it's going to only take into account whatever class that you extend on the player's script, and it's going to create a new one of them, basically injecting your logic into this new class, which is not what you actually want, because maybe your player has a reference on the scene tree to other nodes. Like if you are using a character body for your player scene, it probably has a collision shape as well, right? And this is not going to be instantiated. So this is the major problem of using the new keyword for nodes. Instead, it's always recommended to use the instantiate method on the packed scene so that you can recreate the whole node hierarchy, and then you're going to take this reference and add it as a child of another node so that it can be processed. So these are the major ways that Godot offers to create objects in real time dynamically in Godot Engine. You can use the instantiate on PackedScenes, which again are very specific kind and very special kind of resources that will create nodes and node hierarchy. And you can use the new method to create instances of objects in general. So this is the rule of thumb. If you want to create a new instance of a resource, you can use the new method. If you want to create an instance of a packed scene, you use the instantiate method. And if you want to solve this issue of instantiating objects in your game world forever, you can create a spawner scene, a spawner node that you can reuse across your projects. To be very honest, I don't know why Godot Engine doesn't have a spawner node by default, because it's very simple to create one of them and it's very useful. And if you want to create yours, I will highly recommend you to watch my video about creating a spawner object so that you can use them across your projects and have this issue of creating instances of game objects in your game world solved forever. You won't have to deal with that anymore. By mastering these 3 skills, you'll be able to make your very first game. On my mentorship, Mission Selene, I teach my students how to master these 3 skills within the very first day, so they end up the first day with a playable experience that they can share with their family and friends. The Mission Selene is a tailored mentorship where you present your learning goals, and I will create a gamified learning experience so that you can achieve them within 6 months. If you got interest, check out the link in the description so you can schedule a free class and see if my teaching approach matches your learning goals. But that's it. Thank you so much for watching. Keep developing, and until the next time, see you there.